A good day, dear colleagues. With thankfulness for this opportunity, I would like consider some aspects of not computer, but the own human brain-aided generation of fundamental strategies for design, synthesis, and testing the antiviral drugs. And after focusing on the key problems, we can search their solutions using the computer-aided modeling capacity. It can be represented by the STEM and first of all, about small and macromolecules in view for basic principles. The biologic life, existence, and evolution is naturally progressed from small toward great molecules forms. And there are lipids, proteins, hydrocarbons, nucleic acids, and others. The unique compact concentrators of these vital biopolymers without small molecular ballast represents extracellular viral particles, the virions. They in fact, the maximally compressed interbiopolymeric nanocomplexes. Within the viral life cycle, this fact is very important in view for any therapeutic counter-intervention in a viral life cycle, which could be divided conditionally into 4 stages. First, extracellular virions, then second, entry into cell, third, intracellular replication, and fourth, assembly, maturation, and release of new virions. Only the third stage involves small molecules as metabolites for biosynthesis, while other stages dominantly supported by biopolymeric macromolecules and their nanocomplexes. Therefore, the stages first, second, and fourth can and should be a natural priority for adequate neutralization, but exactly macromolecular scale drugs. The first task is a formulation and implementation of some relevant principles and criteria within the preference for macromolecules on the indicated stage. The first is solubility in aqua media. Second, charge regulated selectivity towards the positively charged virions. Used Coulomb forces to be attracted by negatively charged cell receptors. Exactly, the polyanionic polymers may be most effective interceptors of the virions in competition with cell suppression and adsorption of virions on cells. The biomotivated criteria should be completed by chemical requirements for ability to bind targets by a doubly effective manner using both ionic and hydrogen bonds simultaneously. The most suitable can be intrachain inserted fragments of succinic acid that easily obtained from copolymers of maleic anhydrides. Moreover, the anhydride centers of this polymer are excellent points for covalent linkage of desired ligands in the site positions of polymeric chains. We led us to the resulted variant of basic formulation and structural parameters which allowed us to regulate the required properties, including non-toxicity and antiviral activity. In this case, this is antiviral activity, not direct, but immunomodulated. Finally, we come to the displayed two copolymeric structures as sliders, and following bioevaluation in vivo revealed highly significant capacity of these polyphenolic compounds, protecting mice or rats against lethal doses of nairoviral infections. The next step of the polyantivirals development was oriented to combining the immune-mediated potency with an additional capacity for direct antiviral targeting impacts. This task was taken into realization via chain side positions modifications by ligands of indesired combinations and variations. We proposed an ability of the activations to detectable levels of proposed bioactivity due to a rational conjugation together on the prepared platforms of polymeric chains. Simultaneously, similarly, macromolecular programming the proteins and nucleic acids biopolymeric chains by certain combinations of side groups, we hope to find novel artificial combination of so-called synthetic polymers, which could program these polymers towards various specific targets. And today we have at least 7 original generations that possess many folds more higher and wider antiviral activity in comparison with known small molecular prototypes. The correspondent indexes of selectivity for inhibition of HIV, influenza, cytomegaloviruses are displayed. Of course, some of that polymeric compounds should be investigated in details, applying modern possibilities of computer-aided modeling. And first of all, there are generations 3 and 4, where the norbornone terpenoid-related and adamantane-derived site ligands has been used in comparison with first and second generations. These small molecular prototypes, such as rimantadine and similar, are well known to be fairly good inhibitors of some influenza type viruses, but without any without any significant protection against other viruses. However, considered her approach to the polyantivirus implies novel possibilities for powerful amplification of the small molecules potency due to their rational integration into the polymeric macromolecules. That has been first demonstrated experimentally by our research group in relation to remontadine-resistant viruses of influenza and HIV, particularly the glycoprotein GP41 being a key mediator of HIV fusion, was found could be the most probable nano-target of anti-protection by these polymerins. The small molecular cycles inefficiency against HIV fusion will explain the docking modeling that revealed binding energy that to be too slow. It was too slow to be stable blockers. They observed multiple binding permitted CITES allows conclude that these small molecules capable only local attacks scattered in the space and time. However, the required possibility can be achievable hypothetically on basis of integrated polymeric chains. The docking and molecular dynamic was applied. This is a target, typical nano object. The docking of small size structural fragments from backbone of polymeric chain as well-side ligands and linkers were performed with following stepwise elongation of models toward bigger parts of polymeric antiviral molecules till the scale that permitted by docking program applied. Future, the data obtained were used for extrapolation to scale comparable with original polymeric compounds. The studies were completed by molecular dynamics, particularly of the more longer models. And the binding energy were estimated. The results obtained are in well correlation with experimentally detected anti-HIV activity in vitro. Finally, the three models of models of the target binding were found axial belting and combined. Independence on the degree of polymerization and in comparison with grade of side modification by hydrophobic carbocyclic ligands, the anchors. In view of important role of the polymeric degree related to molecular mass, the next task of the spatial modeling was oriented towards the problem of the mass control and the practical synthesis. For regulation of polymeric chains propagation during the polymerization, commonly chain transfer agents are of irreversible or reversible models are used. However, this methodology get some problems because of tritiocarbonate residues of the raft agent can incorporate into the center of the chain, and the benzene cycles on the tails, both tails of the chains. And this can modulate the biological activity. Really, the docking modeling and molecular dynamics modeling demonstrate the great decrease in the bending energy if the models contained the micro-inserted groups. Therefore, we get the needed to reverse correction for the synthesis methodology. The next problem, beside outside the molecular mass, is isomerism regulation of the chain alternating radical cyclical polymerization of divinyl ether with maleic anhydride hypothetically could assume up to 256 variations of isomerism. Of course, some of them are predictable, referable, but no reliable information in this regard was found. Therefore, then quantum chemical investigation was performed with and all considerable routes of subreactions and their activation energies and enthalpies were estimated, mapped, and analyzed. Crucial points.
1 minute.
1 minute. This research result in ability to modulate this isomerism and related bioactivity. Current results and prospects. The sets of novel high effective poly antivirals was designed synthesis successfully tested and partially modeled, but some other part are not tested at all. And the prospects is not only HIV, but other viruses, Ebola, Corona, and others. Thank you for your attention.